Hello, my great physicists. Welcome, all my science students. Welcome to today's class in physics. Today, we'll be discussing equations of motion. Recall in the previous class, we treated equation of motion. We just explained it. And today, we want to solve some example under equation of motion. So, under equations of motion, we have the first one, V equals U plus AT. Second one, S equals UT plus half AT squared. The third one, we have V squared equals U squared plus 2AS. And an additional one, which is bonus, S equals V plus U over 2, then times T. V represents your final velocity. U represents your initial velocity. A represents your acceleration, T represents time, and S represents distance. We all remember them and their units. So now there are some things to note. One, whenever you are solving questions on equations of motion, we use U equals 0 when a particle or a body starts from rest. Whenever a body starts from rest, U is equals 0. U is equals 0 when it starts from rest. Secondly, whenever we are told that an object or a body stops, when it stops, so the place where it stops, our final velocity, which is V, is equals 0. So if an object accelerates uniformly, like is not changing, like it's called the acceleration is constant. Whenever the acceleration is constant, we have that A is equals 0. So these are like the three things you need to note. Okay, let's solve this question on the board. A particle accelerates uniformly from rest at 6.0 meter per second squared for 8 seconds and then decelerates uniformly to rest in the next 5 seconds. Determine the magnitude of the deceleration. So now the first information they gave us the acceleration, which is 6.0 meter per second. And they gave us the first time, which is what? 8 seconds. So, and then decelerate uniformly. So this is the final time. So we call this called T2 is equals what? 5 seconds. So first, we are going to find the final velocity for the first description. So we're using the first one, which is V is equals U plus AT. V, we are looking for V. Let's call it V or V, right? So V1, U1. Let's use V1, U1, T1. We are looking for V1. Then they said it starts from rest. So U1 is 0 plus, this is 6 times T1 is 8. So we have that V1 is equals 6 times 8 is 48. So we have 48 meter per second. So this is the final velocity for the first process. Then second one, we have V2 is equals U2 plus AT2. So our final velocity, they said determine the magnitude of the deceleration and then decelerate uniformly to rest. Decelerate uniformly to rest. So meaning that the final velocity is 0. This is equals, our initial velocity for this one will be this V, which is 48 plus, we are looking for the acceleration, the deceleration, then times, what is our T? Our T2 is 5. So we have 5 times A is 5A is equals, this going over, we have minus 48. So we have A is equals minus 48 over 5. So we have A is equals minus 48 over 5, which is minus 9.6 meter per second squared. So because we have minus here, meaning deceleration. So deceleration is the opposite of acceleration. That means acceleration goes up, deceleration comes down. So we can say the magnitude of the deceleration is 9.6 meter per second squared. So this is the value, 9.6 meter per second squared is the magnitude of the deceleration. On the board we have an exercise, so we are able to solve one question because the video is becoming too long. That was why I said to solve only one. So I'm going to give you an exercise for you to do. So on the board I have a body accelerates uniformly from rest at the rate of 3 meters per second squared for 8 seconds. Calculate the distance covered by the body during acceleration. So you have to calculate the distance covered by the body during acceleration. So I'll be under the comments marking your answers. So like, comment, and share this video. If you have other questions, you can ask under the comment section. Thank you.